This is section 2.4 in pre-calculus. So we talked about the parent functions. We talked about function notation. We did all the transformations. And so now we're going to go to piecewise functions. And I find that students always get a little scared by this piecewise functions where you put multiple graphs together, but you got to let that go because these are never going away. In fact, these are going to become more and more important for us. And you just got to see these as graphing any other function and you're just erasing part of it. That's it. Okay, so a function that is made up of several pieces. All right, I before E except after C. I don't know. Is that right? Did I spell that right? Okay, pardon me if I didn't. Function that's made up of several pieces from different functions, ironically, is called a piecewise function. I was kidding about the ironically. Okay, so several pieces from different equations, you put it all together, you call it a piecewise function. A piecewise function may or may not be continuous, meaning the different pieces might not connect. They might connect, they might not connect. It doesn't matter. In other words, it may have breaks or holes in the graph. Okay? So, with that being said, on number one, I have two pieces, all right? I'm going to graph this x minus 2. That's just a line. I'm going to graph that whenever x is less than 1. And I'm going to color code here. And then the x squared, I'm going to graph this parabola in pink whenever x is greater than 1. So something that's kind of helpful that I haven't really stressed that much before, but I think it's helpful on piecewise, is to start by putting in kind of the endpoint. In other words, this line, I want it all the way up until x is 1. Well, when x equals 1, the y value is -1. So 1, -1 is going to be the endpoint for that first piece. So all the rest of it, all the rest of that line is going to fall to the left of that because that's when x is less than 1. So how would I graph this line x minus 2? Well, isn't that the line that has a y-intercept of -2 and a slope of 1? So it makes sense that it hits that up 1 over 1. I could keep going this direction. Now, if I were drawing the whole thing, I could say, oh, there it is. But we already said I only want the part of that line where x is less than 1. So I'll just draw it from this side over. Okay, so there's the first piece. And so I'm going to color code mine. The second piece, the parabola, so the endpoint of this one is when x is 1. So if I plug a 1 in for x squared, that gives me +1. So the endpoint of the parabola when x is 1 is +1, right? So I'm going to draw the parabola that's to the left of that point. But keep in mind, this is the basic parabola. So think about it. If I were just drawing the full basic parabola, it would do this kind of thing. But I only want the part where x is greater than 1. So I only want this side of the parabola, which means I'm deleting this side of it. The only thing now I need to keep in mind is, did you notice that on that one, there's no equal to? It just says x is greater than 1. So that means that one's going to be an open circle because it doesn't have the equal to. So in this case, they did not connect. Okay, great. So it doesn't matter. So you can either put those endpoints on first or you can kind of worry about them last, whatever makes sense to you. But just keep in mind, those endpoints are somewhat significant. All right, so x plus 1, that's just a line with a y-intercept of 1 and a slope of 1. So if I were graphing the whole thing, again, I'd be drawing the whole thing, but I only want the part of that line where x is less than 0. So I only want the part from here, this direction, less than left. So I'll erase this part. Now, I do want to think about the endpoint. In this case, it does not have an equal to, so that one's like an open circle right there. Okay, so now let's think about, in this case, this second piece is another line, right? It has a y-intercept of +1, which means it hits right there on that hole. Okay, and then it has a slope of -3, so down 3 over 1. Again, in this case, since I only want the part where x is greater than 0, that means I only want this side of the line. So on this particular graph, do you see what happened? The blue line had an open circle. The pink line had a solid dot that like filled in that circle. So overall, these two pieces connect. Okay, great. I mean, it's fine if they do, it's fine if they don't. But I want to know if they do or not. Okay, number 3, how is this harder or different? There's just 3 pieces. Okay, so again, just do one piece at a time. So the first piece is x cubed plus 1. So let's just think about x cubed plus 1. If I were drawing the entire x cubed plus 1, it would be like this. So again, if it helps you to draw the whole thing, do it. That's why we use pencils or erasable pens. The only part of this cubic I want to keep is when x is less than 0. So from 0 over here, that's the only part I'm keeping. I don't want this part on the other side. Notice there's no equal to, so that's an open circle. Okay, and then for the middle piece, now this is an absolute value graph. So for now, I think what I'll do is I'll ignore the 0 to 2 and erase it at the end. So I know this absolute value is 3 units to the right, 2 units up, and it's opening down. So if I were drawing this entire thing, it's doing this kind of thing, right? If I'm drawing this entire thing, but I only want the part where x, and the way I read this is to say x is between 0 and 2. Well, here's where x is 0. Here's where x is 2. So the only part of that absolute value graph I want is the part where that's between 0 and 2. So it really just looks like a line. I won't get rid of all of the other stuff. And then do you notice both of those have an equal to? So those are both solid dots, okay? And then the third piece is a parabola. It's moved 3 to the right, 1 up. It opens up. So again, if I'm graphing the entire thing, it's this. I only want the part where x is greater than 2. Here's where x, here's where x is 2. So I only want the part over here. Don't want this part. But on this one, notice there's an open circle because there was no equal to. Okay, so in this case, I have 3 pieces and none of which are connected. Okay, that's fine. Okay, number 4, what if we go backwards? What if I give you the piecewise graph and you write the equation? Well, I think the first thing to do is decide, well, how many pieces do you see? On letter A, I see 2 pieces, right? I see this side when x is less than 4. And I see this side when x is greater than or equal to 4. Okay, so let's go to the blue piece. Well, if it's just a line, could I do mx plus b? It looks like the plus b is 2. And for the slope, doesn't it look like it was up 1 and over 4? So I think this one is going to be 1/4 x plus 2, mx plus b. And then for the second piece, if it's just a horizontal line, isn't the equation just y equals? So would you agree that this horizontal line is down here where y equals 1? And remember, the f of x is your y equals, so all I need here is 1. That's like saying y equals 1, and I only want it when x is greater than or equal to 4. Okay? So on letter B, I see 3 pieces. So first I see, I'm going to do this. First I see this line, and then I see this parabola, and then I see this line. So I see 3 pieces. So how about we divide it up first? So the first piece, it looks like when x is less than 1. Now, what I don't know is if the blue line has an open circle and the pink one fills it, or if the blue is a solid dot and the pink one is open. It doesn't matter. Just let one of them be open and one of them be closed. It doesn't matter. So the pink one is when x is between 1 and 2. Again, over here where the pink and the green meet, I don't know which one's an open circle and which one's closed. So just let one of them be open, one of them be closed. So let's say this one is equal to and this one is equal to. And then the green one is when x is greater than 2. Okay, so there's my 3 pieces. So the blue one, in order to do an mx plus b, I need to know what the y-intercept is. Well, it looks like the slope is 1 because this did like an over 1, up 1. If it were to go over 1, up 1 again, if it were extended, I think it would intersect right there at 2. even though it doesn't extend that far, if it did, that's where it would intersect. So that means the y-intercept is 2. So this is going to be the equation x plus 2, slope of 1, y-intercept of 2. And then the parabola, well, I know it opens down, and it looks like the vertex is up. It has been shifted up 2. So I don't think it's moved left or right, but I do think it's up 2. And then the third piece is just a horizontal line down here when y is negative 2. Okay, I hope you can tell what I've got going on here. So that equation went with that, that equation went with that, and that equation went with that. Okay. All right, now this time, I'm not saying you have to graph anything. I'm just saying, how do you do function notation from a piecewise? Well, for a, f of negative 1, what that means is, how do I know which piece to use? There's 3 pieces. How do I know if I plug negative 1 into the first, second, or third piece? You don't put it into all of them. Well, you put it into the piece where negative 1 is defined. On this one, do you see because of this equal to, negative 1 is defined on the middle piece. So I'm going to have the square root of negative 1 plus 1. I'm putting it into the middle piece. Well, the square root of 0 is 0. Okay. And then which piece is it 0 defined? Well, I think, doesn't 0 also fall on the middle piece? So if I plug in a 0 for x, I get the square root of 1, which is 1. Okay. For which piece is defined at 3? Well, wouldn't that be the third piece because it says x is greater than or equal to 3? All right, if I put a 3 in for x, I've got 9 minus 4 over 3 plus 2. What is that? 5 over 5 equals 1. Okay, so I can also evaluate a function using a piecewise function. So that one was short and sweet.